the final problem, practice number 6. We're revisiting a function that we looked at in class. So we have the function f of x is this rational function x minus 3, x plus 2, and part A asking you, can the intermediate value theorem, the general one, be applied to f to guarantee that f of c equals -3. So our y values of interest is -3, and our interval is -1 and 4. So first thing, step 1, into checking if the intermediate value theorem applies is you need to verify if the function is continuous on this specific interval. So in class we had talked about that this function has a discontinuity, specifically an infinite discontinuity at x equals -2. So discontinuity -2 is not between -1 and 4, therefore we can conclude that f of x is continuous on the interval. So let's write that first. So let's see. Since f of x has a discontinuity at x equals -2, which lies outside the interval -1, 4, f of x is continuous. Okay, so that's 1 point towards the function allowing us to use the intermediate value theorem. So that's one thing we have to verify. The second part is that -3 is between the y values corresponding to -1 and 4. So we gotta do some work there. So f of -1, gotta plug it in. So -1 minus 3 over -1 plus 2, that gives us -4 over 1, which is -4. Okay, and then we have to also do find f of 4, which is 4 minus 3 over 4 plus 2, that gives us 1, 6. Okay, so just to kind of clean it up, we know that f of -1 is -4, and then f of 4 is 1, 6. Okay, so now we need to check, is -3 between -4 and 1, 6? And the answer is yes. Therefore, the intermediate value theorem applies, and we can find such a c for some x value between -1 and 4 that will result in the y value of -3. So let's write that sentence first. So since -3, whoopsie, nope. -3 is between f of -1 and f of 4. The intermediate value theorem applies and guarantees that f of c equals -3 for some c in -1 to 4. So since f3 and -3 is between these two values, the intermediate value theorem applies and guarantees that f of c equals -3 for some c in the closed interval -1, 4. Okay, so for part B, now that we know that there's such an x values that results in -3, then we can move on to the next step of actually finding the x value. So we're taking our function. To answer that question, we need to take our function, okay, and we want to find when it equals -3. Right? We're trying to figure out what x value would result in that function equals -3. So now we just have to take into account how we solve equations. I'm just going to cross multiply here. So we have x minus 3, and then we have -3 times x plus 2. And so we have x minus 3 equals -3x minus 6. And just solve this equation. So I'm going to add the 3x, so I'm going to get 4x. Add the 3 on both sides. So you'll get equals -3. That implies that x equals -3 over 4. So, in conclusion, f of x equals -3 when, whoops, let's see, looks like this better. So f of c equals -3 when c equals -3/4. So the c value, the x value that will result in a y value of -3 has to be -3/4.